Hi, everyone. If you're just tuning in, welcome to a marvelous Math Monday. Oh, it's a murky Math Monday out there. It's raining like crazy, but it's a good snacking Math Monday. My son is just crushing a snack over here with a minimum of mess. I hope the ants don't carry him away. But anyway, we'll get him tidied up. And there's no helping it now. Okay, so let's keep going. If you're just tuning in, we've gone through 33 of the 77 questions. So this marks the halfway point, and you're going to notice the speed goes up. Okay, Liam sells sandwiches at the arena. He earns $10.50 per hour plus 40 cents for each sandwich he sells. How many sandwiches does he need to sell during a 6-hour shift to earn $125? Well, he earns $63 from his hourly rate. How do I know that? Because I happen to know that 6 times 10.5 equals 63. Check it with a calculator if you don't trust me. Okay, so then we would have this equation. Earnings, E, is equal to 0.4 times N, the number of sandwiches, plus $63. All right. And we want to know how many sandwiches to sell to earn $125. So that's our desired earnings is $125 is equal to 40 cents per sandwich plus $63. Now I want to isolate N here. So I am going to subtract 63 from each side. And that will give me $62 is equal to the amount of money he needs to make for selling sandwiches. And since he makes 40 cents per sandwich, now I just need to divide both sides by 40 cents.
Daddy, I'm behind you.
I noticed. So now let's do it. 62 divided by 0.4. Why don't you do that in your head, Mr. Jennings? Well, because I got other things I need to do. Okay, 150. So this is the amount of sandwiches he needs to sell. Let's keep going. All right. The cost C in dollars to print N leaflets is given by the okay. So the more leaflets you print, it costs 3 cents per leaflet, but 35 bucks to get started. What's the cost of printing 900 leaflets? Well, 900 times 3 cents, that would be $27 plus 35 would be $52, $62. There we go. That's it there. $62. That must be it. Must be it. All right. I told you the speed would go up. Okay, well, how did I do that? Okay, well, to print N leaflets. N is a number. We just don't know that number yet. But now we do. Let's say, well, how much for 900? So then you answer this question. Okay, cost is equal to 35 plus 0.033 3 cents per leaflet. How many leaflets? 900. Do this on a calculator. I'm pretty darn sure you get 27. Then you add 27 to 35. I mean, it could be that one, but it's not. That would be too few. Buddy, don't be standing on the furniture like that. You're gonna fall or something. Give me the heebie-jeebies. Oh, geez. My mental brain is like, it's distracted by something. I'm not sure what, but, let's see. 0.03. Aha! It's 54. Okay, I did 0.6 instead of 0.3, which is 2 times too many. 54 happens to be twice 27, so it's indeed just verified. Okay, just let's keep going. All right. Scientists find that the height of a person, h in centimeters, is related to the length of a person's femur bone. Okay, F in centimeters according to the following formula. All right. So your height grows as your femur grows. Okay, if your femur is long, then your height grows by about 2.24 times the length of your femur. Okay, there's your femur bone. It happens to be the longest bone in your body and the biggest bone in your body, I think. So let's keep going. According to the formula, what's the height of a person with a femur bone of 48.6 centimeters in length? 48.6. So this is what we do. Okay, we copy out the formula. H is equal to 69.09 plus 2.24 multiplied by the value that they gave us, 48.6. 48.6. Okay. And then we do that on calculator with following BEDMAS. All right. So let's follow BEDMAS here. Boo, 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 boo. We are going to put this over here so we can see it. 2.24 times 48.6. Notice I did the multiplication first before that addition. Why? Because bedmas. And then I add 69.09.
Daddy,
Yes, Mr.
is
Miles.
there like a laptop?
Oh, yeah, it's a little bit like a laptop. Oh, it is a laptop, actually. So 177.954, so about 178 centimeters. 178. So I need to get my hand on that. There we go. So it's this one. There. Okay. I said the speed would increase, but I didn't count on some delays. Tamira needs to rent a car. She considers the following price equations where C is the total cost in dollars and N is the number of days. Okay, so cars does not charge you an upfront fee. They just charge you $50 a day. Okay. Drive Away charges a very high flat fee of $125, but only $15 a day. Okay. And Cheapies Rentals is $50 a day and $25. Sorry, $50 flat fee and $25 a day. Okay. Which company should she choose if she's planning to rent the car for at least 10 days? So she's going to be renting it for at least 10 days. Okay, so let's compare. Drive Away, I think, might be a good candidate. Okay, because Drive Away is going to have the lowest cost per day, but then it's got this flat fee up here. So that one is going to, if I just input 10 for N, that one is going to equal 15 times 10 is 150 plus 125 is $275. And then let's see, Cheapies Rentals, that would be 250 plus 50, that would be 300. And this one would also be 300. So Drive Away is the best. You could graph them and you would see that Drive Away is going to be the best for 10 days or more. Okay, you would also see that on the graph. It would be the lowest line. Are you okay?
Yeah.
That wasn't your head hitting the table or something? What was it? Okay, don't be playing with that snapper there, okay? Leave that alone. That keeps the table together. I want to what did you do there? Oh, you undid that. Okay. Your head's okay though. You did not just hit your head? No, okay. Don't play with that, please. Okay. Nadia lives 11.4 kilometers from school and rides her bike to school every day. Okay, this equation distance is equal to the distance that she starts away from school minus 0.6 times t, represents the relationship between d, her distance from school in kilometers, and t, her time spent traveling in minutes. If she leaves home at 8:05, what time will she get to school? Okay, cool. Cool. I love this question. It's so great. All right. So we want to know. This is how we would do it. Okay. You would say D is equal to 11.4 minus 0.6 t. All right. This is the equation. I copy it out, and then I say how much time do I need to reduce that distance to 0? Okay. So there's going to be some amount of time where distance is going to be equal to 0. Notice I just substituted in 0 for distance. That's saying when does she get to school? When is her distance from school 0? Right? That's going to be equal to 11.4 minus 0.6 t. All right, now I want to get all my numbers to one side and all my variables to the other side. So I'm actually going to add 0.6 t to both sides here. So this will be 0.6t is equal to 11.4, and then we're going to divide by 0.6. Why am I dividing, Mr. Jennings? Why don't I subtract 0.6? Well, I divide here because I am multiplying 0.6 times t. The opposite of division is multiplication. So this will cancel here and cancel here, and this will be my answer in terms of number of minutes required. Okay, 11.4 divided by 0.6, which is not getting done in my head right. No, I can do it. It's 19 minutes. T is 19 minutes. There we go. My mental math is here. If you don't trust me, I don't trust me. So try it. 11.4 divided by 0.6 equals 90. I'm back. Well, part of me anyway. I'm actually feeling better than when I started these videos. So it takes 19 minutes. She leaves at 8:05. 8:05 plus 19 minutes equals 8:20. Or there it is, 8:24 a.m. All right, let's keep going. A computer decreases in value over time. Sad but true. The relationship between the value of the computer V and dollars after T years is written as the equation. So this is telling me the computer initially was $2,100 and it loses $300 per year. A line representing the relationship is graphed. What does the V-intercept of the line represent? Okay, so the V-intercept, that is over here. I already talked about it. Cool. Okay, the V represents the initial value of the computer. Why? Well, that's at time 0. And we read up here and we say, what's the value of the computer? Well, that's its initial value, the value at time 0. That's where it starts. Let's keep going. Does that what I sound like, Mr. Miles? Natter, natter, natter. I think I maybe do sound that way to some students. Oh, my drawing tools came back. I don't know why, but they came back. Cool. All right. The total cost of printing yearbooks is made up of a fixed setup cost plus a cost per book. Graph A represents the total cost of printing yearbooks last year. Graph B represents the total cost of printing yearbooks this year. So here's A, this line, and here's B, this line. Okay? And now they're going to say which statement is true. Okay, so let's analyze these. I need to see all of it. There we go. Okay, hold on one moment. All right, let's carry on. So, which statement is true? The fixed setup costs for printing yearbooks last year and this year are the same. Well, that's not true. I see the fixed costs as the initial costs, and they're here and here. They're clearly different. Different? How? I'll zoom in. Okay, see? See how they are? They started at different values. And let's see. Now, the fixed setup cost for printing yearbooks this year is lower than the setup cost for printing yearbooks last year. B is the cost this year, but it's actually the fixed costs were higher. So that's not it either. The cost per book for printing this year is more than the cost for printing book for printing last year. No, it's not. Look, the cost per book is lower this year because the slope is lower. Here, the slope is higher. So this means higher cost per book. This is lower cost per book. So C's not right. So D must be it. The cost per book for printing last year is more than the cost per book for printing this year. That one's true. Look, the slope here, the rise over the run, is bigger than here, the rise over the run. Okay, there's a bigger slope here. So this one is it, and that means D. And there we go. Mr. Miles. No one needs to see that. That's not going to help anyone learn math. It's quite distracting. The total cost of hiring Beth's plumbing services is represented by the equation C is equal to 50T plus 70, where C is the total cost in dollars and T is the time in hours. Okay. Next month, the rate will change to $60 per hour, but the initial charge will stay the same. Okay. So the rate will change to 60 per hour. What's the following describes how the graph of the relation will change. Okay, so the steepness of the line will increase. Yes, that's true. Okay, the steepness of the line will increase. Okay, they're increasing their rate per hour. Okay, so if before the graph started at 70 and went up at $50 an hour, now it still starts at 70, but it goes up faster at $60 an hour, so it's steeper. Identical bottles are packed in a box. The box will hold a maximum of 38 bottles. The relation between M, the total mass of the box, and N, the number of bottles in the box, is represented by this equation. M is equal to 500 times the number of bottles plus 800. So which of the following are possible integer values for the variable N? The box will hold a maximum of 38 bottles. Okay? So the relation, which of the following are possible integer values? Okay, hold on one moment. All right, let's carry on. So Which is the possible integer values for variable n? N is greater than 39? Well, that's possible. I mean, it could be exactly 38, but that's it. What else? N is greater than or equal to 0. Yeah, that's true. But n is greater than 0, but less than 39. N is greater than or equal to 0, but less than 39. This one here, D. Okay, we could put 0 bottles in the box. We can't put a negative number of bottles in the box. So we clearly have 0 or more, greater than or equal to 0. But it has to be less than 39 because 38 is the maximum. Miles, can you knock that off, please? All right, let's keep going. 2 more questions and then I'll sort them out with an activity. Okay, so Alfredo and his wife Jody work in a restaurant. Alfredo received an average of $15 in tips for each of the 55 tables. Hold on one moment. I think it's activity time right away. Okay, so he gets a $15 a tip for each of his 55 tables. Well, he's doing pretty well. The average is $55 tip, and he can do 55 tables a night. Oh my, that's really good money. Really good money. That's crazy. Jody, on the other hand, receives even more money, $20 in tips for each of the 60 tables she served. Yeah. All right, so they're planning a weekend trip. Alfredo will pay a total of $220 for their hotel room, and Jody will pay $160 for their rental car. How much of their combined tips will be left over after they have paid for their hotel room and rental car? Oh, I love this question. Gives you an idea of how the money can work. So let's figure out what's their total tips, and then do their total that they pay. Okay, that's how I would do it. So total tips first. Total tips. And so we would have $15 times 55 tables for Jody. And then we would add $20 times 60 tables for, sorry, this was Alfredo and this is Jody. Okay, so now let's add up their total tips. 15 times 55 is, I don't want to do that in my head. 55 times 15 equals 825. Okay. 825 plus, notice this is happening in Bedness order. This is $1,200. Is this per night or per week? Like that could be per week and you would still say, well, I'm making do at the restaurant. But if you can make that kind of money per night, like, wow. But I don't think you can serve 55 tables a night. And those of you who have done some server work can let us know. All right. And then we add these together, and that's $2,025. Notice whenever I can do it in my head, I do it in my head. And you should too, so that you practice these things as well. The only reason I skip out on doing something like 15 times 55 in my head is because I'm under some time pressure, because you all said, hey, Mr. Jennings, we want you to answer every single question. And I'm taking that to mean that you really want this video. So I'm doing that for you. Okay, so anyway, here we go. That's total tips. Circle it. It's a useful number. And notice that they have that there as a false answer. How much of their tips will be left over after they pay this plus this? So they're each going to pay these. And if we add those together, that's $380. This minus 380 will be this number. Yes, that's correct. Because you do minus 340. Sorry, you do minus 400 and then add 20. So minus 400 from that and then add 20 is indeed that number. All right, so that was that one. That will do that. All right, last one for this video. Theo plans to purchase a new long-distance cell phone plan called the Silver Plan. Under this plan, the telephone company determines the monthly cost using the following charges. So here, it's good to underline things like base fee, $30 a month, and then it includes 150 minutes of long distance. And then the cost for all minutes over 150 is worth 15 cents per minute. Okay. With the Silver Plan, how much will it cost Theo to talk long distance for 230 minutes over 1 month? So it's important to note that the first 150 minutes are free. So how many minutes does he have to pay for? The total minutes he uses minus the free minutes. Okay, so he will have to pay for 80 minutes. And let's produce a little equation. Cost is going to be equal to the flat fee, the base fee here, $30, plus the cost per minute, 0.15 multiplied by 80, because that's the number of minutes he has to pay for. 80 times 15 cents is $12. So the cost is 42. Okay, check this with a calculator if you don't trust me. All right, then that's it for this video, and I'm going to make some more. So thank you very much for showing up for your learning. If you've gotten this far, my goodness, I should start putting some secret words in here. The secret word for this one is chicken noodle soup, because that's what I have to put in an order for, and my wife is going to pick up on the way home so that I can start feeling better. All right, everyone, chicken noodle soup. Email me chicken noodle soup for a high five. Bye for now.